How are you doing? We're gonna do it. Yeah, we're gonna do it for real. Did Mark Anderson kidnap us? No, I didn't have a meeting either. Mark, if you're seeing this, hello, let's chat. I don't know. How are you guys doing? By the way, it took me. I have to come clean. I actually procrastinated on this, so I kind of made a plan um, to for the loci thing, right? So the memory palace, a rough plan yesterday, no, 2 days ago, right? And then yesterday I didn't do anything until the afternoon, and I went straight to Montreal to meet another Yassine. So we had tea. Yassine, if you're watching this, thank you for the tea. And then from 7 to 2 p.m. 2 a.m. I was just cramming it, right? So I did the whole palace stuff, stitched everything together, and then I just put all of the elements in this big brain, and made the visualization. And now it's good. I think I can do it. So hey, hi Nani. It's gonna be a fun one. I think. If you guys are asking why the heck are we doing this, there is some link, right? That I I cooked in here for like a word model, and why this thing is even possible. Like, why can I in like 5 hours inject so much information that is arbitrary in my brain easily, right? Like I didn't sweat or anything. It just took me some time, and the hardest part was just deciding like how to chunk this stuff, right? It was not even to actively encode it. Actually, some of them I just encoded it once, and then it was good. And when I go through the stuff, I don't even see the image. I just know the thing is there. So it's a bit weird, but it has to do with how our brain function, right? When I did the periodic table in my brain, there was no palace. It was just an apartment. My memory palace is actually. Oh, the voice is low. Sorry. Maybe if I can boost it up. Is it better now? Are we? Are we good? Is this better? Right? Let me know, Mass. Are you the guy from X? Yes, I'm the guy from X. Aren't we all, right? Aren't we all the guy from X? Um, so yeah, that's the setup, and we can maybe check out a bit of stuff. Remember, right? This is better. The volume thing. Yes, no. I think there's a slight delay when I stream, so thumbs up if this thing you can hear me well. Yes. No. I think so. Yeah. I think people. Yeah. People saying very good. Good volume. Good volume. Okay. 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 Cool. Perfect. So this is perfect. So yeah, what we're gonna do today, I'm gonna go through some amount of neuroscience theory. So kind of tricked you a bit. And then we're gonna actually do the memory palace stuff. I'll show you my setup, right? How I did it, and then I'm actually gonna like do it live. I have the whole thing. I have even blindfold so that you can't say I cheated or whatever it is. I will remove my headphones, and then we're gonna link it back to an important concept, which is world models, right? And the whole JEPA thing from Jan. We're not gonna go fully through the JEPA stuff, but just to get you a sense about like what's the intuition behind, because having a world model is actually super important. And if you want to have one that is useful, you need to be grounded where it's going to be used, right? And usually it's going to be the physical world. Cool, perfect. So let's get started over here. We're doing good over there. Okay. And by the way, don't hesitate if you have any question at any time. Don't hesitate to shoot it. Doesn't matter if it's like just tangentially related to deep learning. I'll take the time to answer it. This is the purpose of this whole thing. So we have a bit of stuff to cover. We're gonna go through the periodic table over here, right? There's this. I have some good recommendation for some other series of video that you can watch after that, and it will get you thinking a bit more about like what the heck is Jan saying here and why maybe he's right, right? So that's what on the program today. But we're gonna start off with rats, actually, right? Just so that you have some intuition a bit about what I'm about to show you actually work, and a concept that is called latent learning, right? So the latent learning, for people that don't know, is just like it's a neuroscientific concept that I'm gonna bastardize right now, and it's just about being able to learn like organically, like without even having any strenuous effort in the brain, right? And there is some stuff that are in the latent learning categories and some stuff that are not, right? So for instance, if you go into a new place and then you just go and walk in the house, right? Like, unless you have high hippocampal damage, right? When you're gonna come back, you can recall where the heck everything was, right? To a high amount of degree. So like, there's some learning that is happening in the background, and you don't even have to think about it. You're just like going through the stuff, right? So for some people, it takes maybe more time to get accustomed to stuff, but you're never completely off of your workers, right? Same thing when like you're like watching some kind of fiction that is in a world, right? You can kind of understand the trail of stuff that are happening. There's some latent learning that is happening in your brain. So this paper is, I think it's a 2022 paper, and basically what they did is just like they're recording, right? They're recording in a rat, and then the rat is going through some maze, and they're just looking at specific neurons. And the neurons we're talking about are in here, in the hippocampus, right? And the hippocampus is a very central region in the brain, right? It's a bilateral structure in the medial temporal lobe, so it's very inside, and it's like there's two of them, right? It acts as a hub for memory, encoding, consolidation, and spatial navigation. This is also like where like there's neurogenesis that is happening in adult. It's crucial for converting short-term experience into long-term stuff, right? Long-term memory, and building maps and environment. And like, you might stop here and say like, why? Like, what's the link, right? Why are we talking about like learning and spatial stuff, right? What's the, you can think about it like, I just want to learn chemistry. What does it have to do? It's like it's outside like it's firing up the same stuff that is encoding spatial things, but you have to take a step back, right? Like, we're primates, right? We're meant technically, right, to be moving and stuff, and then like being on the outside on like 100% basis, right? So like the learning in our brain and in most mammalian brain is very tied to like where the heck you are, right? So it's optimized for this. So you don't have to kind of be very conscious about like, okay, like I'm in this room right now, and then there's a roof here, and like you don't have to think about it. Like, you just automatically do it, right? It's optimized for this. It has like this internal structure that can do it. And then whenever you're doing something, usually you're gonna do the stuff here, right? You're not gonna do it like in some other random places, or like it's like tightly connected in space when you're doing something. So that's why the reason these two things are usually connected. And we're not gonna go through the whole research, but like here, basically what they're saying is that they want to investigate the neural mechanism in the hippocampal neuron in mice. So during latent learning of spatial map, and observe that this is what they observed, that the high dimensional neural state space gradually transform into a low dimensional manifold that resemble the physical environment. So what I'm gonna show you, the cute like a TSNE map, is that it went from being very random to being like tightly like looking like the maze that the mice was in. And like sleep in this particular setup is very useful to consolidate the map. So like there's this long-term consolidation usually in the hippocampal region that like trigger during sleep. And then there's neural reactivation of navigational experience during sleep. So you kind of do a recall of like the stuff that you've been through. So like this is why also like I don't know, well, when when you're moving about, sometimes you may be sleeping and thinking still about it, right? And then when you do it again the next day, you're better. Your brain is kind of doing this stuff again, right? Um, kind of automatically. So overall, these results suggest a potential mechanism for latent learning of a spatial map in the hippocampus, right? So we're gonna link this to what the heck we're gonna do after that to some trick for world models. I'm on my birthday day. Hey, happy birthday, Santi! Hey! So you can watch a recording if it's too much. We're gonna get there. We're gonna get there. Yeah, like the London, somebody said in the Twitter chat, Stefan, like the London taxi cab driver, exactly like that. Like they're able to memorize stuff, but like they have a special map that is getting made. So long story short here, like they're doing a bunch of imaging, and it's like very intense imaging. The rats usually die after that, right? So like they're able to look at the brain in high details, and then it's literally like connected to their brain while they're in the maze, and then they're able to look at all of the little neurons. And long story short is it goes from a mess like a session one like this where like all of the neurons are kind of like doing whatever, they're flexible, right? And then after a few sessions, what happened is that they're starting to consolidate into something that highly resemble and fire in how they're firing of the map in the section. So like the neurons are now going from being all-purpose to being mapping this stuff, right? And then the way they basically usually do that is that they're able to see when the neuron will firing in the space, right? So this is why they can see that like it's now like built for that. So and you have different shape, right? You have different neurons that are acting differently depending on like where the rat was. So it's different rat usually, right? So there, in this case, it would look like this in this TSNE map, and then it will look like that for this one. It will have different shape. It's not like it's just encoding the area or the space. It's actually encoding like all of the spatial property of it. So much that you can just look at the recording and know where they were, right? Like that's the extent of it. So it's really like almost creating a world model of the stuff, right? And the kicker here is that this is before, this is also before, and then this is after sleep, right? Which then correlate a bit more after one run to like this map. So there's more similarity. And then this other one is with no sleep, and there's not that much correlation. So like there is element of sleeping that the brain kind of consolidate the stuff and kind of is able to ship some of this other thing to a more structured and solid state. So yeah, that's long story short. This is what we're talking about here. So the key point is that spatial map are like incrementally constructed with initial exploration, and then after that they're refined. So when you go and do stuff and you look at the things, right, you're kind of processing information like every day. Like you're just continuously doing this. You don't even have to be conscious about anything. And then when you go to sleep and it's offline, then you're able to kind of refine it and like make it stick. Sleep dependent replay is a plasticity driver, right? It's not just like redoing it. It's like actually creating the enough flexibility so that like it stick like that, and you reorganize network for long-term retention so that you can like retain the map usually. This is why I slept tonight, because I needed this map to stick, right? This framework links episodic memory consolidation to navigation circuit, underscoring the hippocampus as a universal memory space integrator. So this little itsy bitsy thing is absolutely super duper crucial, right? Like it need to be there. Otherwise, not only you can't make memory, you can't like even learn new stuff really, right? And there were like patients that had this ablation in the hippocampus in both region, and like they were kind of stuck in what they were. They couldn't like learn new environment. They really couldn't learn new memories and all this stuff. And like they were really stuck in the time they were had this ablation. That was especially for one specific guy, and he had like a massive seizure. So it was not It was not. It was either this or like the guy died. Anyway, there's an interesting bit in the discussion here. So the maps are not only more efficient and flexible representation of experience, but also a generative function, right? Which enable the brain to simulate potential action in the environment without the need for actual physical action. So literally, like the action of creating maps in our brain is central to how we learn, because that's how we can then simulate the stuff, right? And what I did by mapping the periodic table is I simulated this, right? And then I stitched it together, and then I'm able to remember stuff. But I'm highly making use of everything spatial in my brain in order to get that. Okay, so cool. We have a few questions. Happy birthday, Santi! Yay! Happy birthday! It's user 1 for tomorrow also. I won't be there. Spatial image plus sleep equal learning. Kind of. We're gonna see what's up. And it's so cool. I need a cup of coffee to rewatch it. Okay, yeah. Okay, cool. So this is in a mice, right? We're gonna go a bit to something that is more human-like, which is handwriting or typing, right? There was this kind of the debate about like whether like handwriting or like note-taking and stuff or typing was useful for which one was better, and a lot of people seems to miss. Okay, I already memorized the map. A lot of people have missed the thing that like it's not about the notes. The notes doesn't matter. Like you can even write like drawings and like it doesn't matter what you're writing there, right? What actually matters in the stuff is the motion, because the motion then goes into more of a spatial domain, and the spatial domain is what makes stuff stick. So there's a whole study here. This is actually a review paper. You can check it out so that you have a good idea about what's happening. But the gist of it is that the brain region associated with handwriting and with typewriting are different. And the one thing that are different is the involvement of the primary motor cortex and the thing that are more like sensory related. So like the stuff for motion, right? And like involving the stuff for motion is what is triggering a better, deeper learning of the material, right? So anything related to movement, right? And then like moving in space, and then even like when you're writing with your hand, you're kind of moving something in space, right? And you can imagine stuff in your head and then like shape that thing properly. Doing this, right, enable you to have a boost in learning condition, right? So here, the gist of it is that handwriting is a sensory motor cognitive integration task, while typing is largely just symbolic selection. So when you type, there's like you're in a very much more limited space here, and then you're literally just selecting like letters to match whatever you have to write. Handwriting recruit the frontoparietal and cerebellar network. So cerebellar, right? Every time you see that, this is the cerebellum. It's like all having to do with movement, right? Tying spatial planning to memory encoding. So you're able to remember more because now, I don't know, like here, everything that is made for like mapping space kind of is getting created. So you're kind of mapping your stuff, and you see that really well when you're trying to make what it's called a review cheat sheet or like a cheat sheet, right? Like at some point you're actually making a map, because the cheat sheet is not about like putting everything in there. It's about mapping the stuff so that you can recall where they were, right? And like have a good sense about these stuff. So you're actually creating a map to remember a lot of facts. So another case of like hacking your spatial domain. And memory benefit of handwriting come from deeper encoding via multisensory processing and fine motor planning, and spatial feedback from pen paper interaction build like graphomotor engram, which is called motor memory, right? That enhance like literacy, whatever it is. So like what you should get from these to like more neuro related study and review is that like it's a brain made for places in motion, right? Like this is what it was made for. We invented like letters and whatever, right? But like we're in a world which is a bit abstracted from the moving, the motion. So every time you can come back to this, what happened is that you have like almost a superhuman level of learning versus just like seeing the stuff that is very flat and like unidimensional. So if you look at the periodic table, it is actually very flat and unidimensional. Like look at this, right? Yes, you can imagine what hydrogen is or what helium is, or if you work with neon or argon, right? You can know. I can remember nitrogen because that thing is in my lab was looked super fucking dangerous, right? But that's kind of the extent of it, right? Like everything else, if you were trying to like remember the ordering and all of this, it's very very complex, right? And yes, you can use the specific ordering of how they were structured to kind of make groups and whatever it is, but the most potent way of like memorizing something as arbitrary as all of this, right, is if you think about it, this whole row, I have no clue. I literally have no clue what they're used for and what good they are. Like zero clue. Carbon I can know, nitrogen I can know, oxygen I can know. Like they are closer to me, right? But most of them I have no like tangible way of doing this. But if you encode it in spatial ways, then you can. And this hack is not even a hack. Like this propensity for the brain to kind of be able to like absorb the information with spatial memory and movement faster has been known forever. The ancient Greek were using that to like plan speech and stuff like that, right? Like long speech that like were lasting an hour and stuff, and they could recite it from memory and things like that. Or like the people that were like saying the Iliad and they were blind, whatever it is, and they just had it in their memory, right? They were able to move through the space and tell the story, right? So the gist of it, I'm going to give you a crash course of it, is you imagine a space, right? Any space, really. It doesn't matter. A space that you know well, right? Or that like you have some like familiarity with it. And like this space, you can create a bunch of loci. So it's like, let's say it like a landmark in the spot. So for instance, like this corner over here means nothing for me, right? This thing under the chair means nothing for me. This one also, that these are not loci, right? Loci are like area in the space. We have a specific attention that you usually put on it. Maybe somebody died here, right, for you. Maybe this is an important spot, right? But for me, it's just like the floor, right? Here, maybe like you were always cooking and then it was stinky, so like it's always here that you were looking at to put the fan, whatever it is. Maybe like your favorite like cup is over here, right? Maybe like you found a mouse here at some point. Maybe here there's like I don't know, your collection of cookies or whatever it is. And then like you can arrange them into a sequence that makes sense to you, right, personally, and then arrange them like a path, right? So I don't know, you start your morning here, right, and then you close the fan or whatever it is, or you open it, and then you go through this motion, and then you do something with them, right? And at each of these loci, what can happen then is that you can take whatever you're trying to learn and literally encode it into something. In this case, they're trying to memorize like the planet of the solar system in order, right? You encode it however you want. It doesn't matter. It matters to you, right? So if you're more of a sensory person, you might be like touching the stuff. If you're more of like a visual person, it might be like very like colorful changes and things like that. It doesn't even have to fit this. It's just like what you think of it, right? When you say mercury, what do you think, right? Maybe you think about like a thermometer, and then there's a heckload of thermometer in the fan here, and they're just falling off like this, right? Like maybe this is what you want to encode. Hurt here, instead of like just thinking about the planet, which may not mean anything to you, you can just put a whole pile of dirt here in your favorite cup. Mars, I don't know, man. You can put like a whole thing of chocolate, like the Mars chocolate bar, in here, and they're all, I don't know, like all rotten or whatever it is, right? And you make it as vivid as possible as you can, right? Doing this will be able to like directly connect to your thing, because if you were to close your eyes right now and think about your house, right, you will know immediately if something moved. Like let's say I put, I don't know, man, like a pool in your living room. You will not go there and be like, oh yes, my pool is over there. No, you will be like, what the fuck is happening here, right? Why there's a pool in here? So you're able to know the difference between something that is supposed to be in the world model and then something that is not supposed to be in the world model. And like we're gonna see it afterward. This is kind of the idea behind like not just contrastive learning, but like energy-based model where there's an objective function and you can have the difference between the objective of the output and what it should be, right? And then this difference is have some salience, some information to it. Okay, a bunch of questions. Academic paper is so cool. Understanding them is another level. Thank you. No worries. That's what I like to do. I should have used this technique while taking my intro to quantum mechanics class to memorize all the different problem set. Or you just do them, right? And then there's different ways you can trigger your spatial kind of areas. You don't have to always just use the memory palace. Like you can like think about it more in terms of like physical sense and like mapping things. If you do that, this is the gist of it. This is what allow you to retain a lot of stuff. How does the brain know which memory to reinforce and which to discard during sleep? That's a good question. It always has to do with salience. What's important, like what was important during the day or what was not, right? So you can reinforce it in many ways, but there's some elements that are absolutely crucial for the functioning of the brain. And spatial stuff is absolutely crucial. You have to be able to map everything all the time. Your brain is made for this. There's no shortcut here, right? So like the brain already is doing this. So if you're able to like use that, then for sure the brain will reinforce that memory easy. Should I use a different place for each thing I want to memorize? Periodic table, order of the planet? You don't have to. This is the interesting part. Like you can use the same memory palace and then like stack different things in there. Yeah, I did that with control healthy people. And we're able to stack like 25 items 3 times. And it still worked. Yeah, but like, don't just rote memorize stuff just for the fun of it, right? If you have to, you can do that. It's a very fast hack, and then you get it done. But the whole point of like learning is to find like more a deeper kernel of truth. If you can look it up, fantastic. Let's just look it up, right? Note on paper versus keyboard. Paper all the way. Okay, cool. So, hi Nibleton, glad to have you here. So, we can go into the interesting bit. I'm gonna demonstrate you the stuff, right? So I learned the periodic table like this, right? This is how we do it. We did it like that. I went into like the P group, right? So, sorry, the S group. I went and learned it here, well, first, like this, right? These two are connected. And then it's like that, and then like that, right? And then what I did here, there was a small, not mistake, but like a difference in the one that I used, this one, right? So actually what happened is I'm learning it like this, and then like that. These two are connected in here, right? So even though it's in the F, the lenthanide and the actinide, in my memory palace, it's these two and then these other two that are connected into like a chain. So you're gonna see it when I'm gonna say it. And then I go like this. I go each of them like this, right, in the D group. And you're gonna see me stop here, right? At this point, you're gonna hear me stop because I have to move into another memory, like another section of the memory palace that is not necessarily connected. So I had to do it because I'm using all my apartments, by the way. So I didn't have enough space. And then I go like this, and this is the done of my second apartment here. After that, I'm going at it on this front like this, like that, and like here, and I stop here. Oh, I'm gonna literally stop right here, right? And then I'm gonna finish with these two like this. And then I'm gonna take a small pause, but not a big one because it's still in the same palace. And I'm gonna go like this here, and then I'm gonna have to go outside of my actual house, and then go like this. Actually, funny thing is Tenesium and which one is it? Astatine sorry, tennyson and astatine are here. So astatine is here, tennyson is right here on this table. Cool. So that's the gist of it. So you're gonna see me move like this. So if you want to check while I'm gonna do it, you can open a periodic table, right? But it will look like that. You can screenshot that if you want to, but it will look like this. And I put all of my notes over here, right? So we can double check after that, like which is where, because like I can literally tell you which loci it is based on just the name, right? So if you tell me, I don't know, let's take one in. If you tell me palladium, right? I know I'm in my 01 second apartment, right? Apartment number 2, and I'm on my sofa, right? This I know. And like, so if I look at it, palladium, it's in the P block here. This is apartment 3, no, it's over here, right? And then I am here in my sofa. You see? I didn't check, and like I just know it's there, right? And I can the cool thing with this stuff is that you because it's a map, right? Like you can go forward and backward, or you can go like this, or you can jump and then go backward and link everything together. So technically, I can also like do it in reverse. I have to double check stuff here to be able to do it in reverse, but like not only like the whole structure. You know, like the relative positioning of anything, really. Okay, any question before I actually do it? Okay, so it's gonna be a bit, may look a bit boring, right? So I'm actually gonna do it here. I'm gonna put myself on the corner, so you can see me at the same time, over here, and then here. Okay. So this is the actual one that you should look at. Well, there's a name here, so wait. I'm actually gonna just use this one, zoom it onto it fully, and just watch out for these two, right? Remember, this one, the lutetium, and then the Lawrencium, right? So this one here and here are actually connected to these two, right? You're gonna see it in how I'm gonna say it. Okay, so here we go. Hope I'm not gonna fuck it up. The periodic table was not too complicated, honestly. It took me 5 hours to put it into the loci. The longest part was to actually put it into the loci. That stuff took me a while. Sorry, to create the loci. Okay, can you see well all of the screen? Okay. So let's actually do that. Kind of nervous. All right. Okay, I'm gonna close my eyes, and you might see me move a bit because I'm actually gonna move through it. Okay. So let's do that. Okay. Perfect. Okay, so hydrogen, and then helium is like at the other side, and then we go back to the first row. First column, which is lithium, sodium. Then we have potassium, rubidium. Then we have caesium, francesium. We have beryllium. We have magnesium. We have calcium, strontium, barium, radium, and then we're out of the first S block. Right now we're out. We're going to the start of the D block plus the two other ones, right? And then you start with scandium. Scandium or scandinium? I think it's one of the two. I think it's scandium. Scandium, yes. And then yttrium, lutetium, larynxium, and these two are the ones that are like outside, right? They're technically in the F block, but I put them into that because of the other image that I showed. And then we go into titanium, zirconium, hafnium, and rutherfordium, right? And we're not done with the D block, but I have to go somewhere else. Where the fuck am I going? Okay, I'm going here. Vanadium, and then neobium, and then we have tantalum. No, tantalum or tantalum, one of the two. And then we have dubnium, we have chrome, we have molybdenium. Then what the fuck we have? We have tungsten, seabornium, manganese. We have technetium. We have rhenium. We have bornium. Iron. And then I have rutetium, osmium, hafnium. And now I have to go somewhere else. And now at this point, I have which word? Okay, here, this one. I have cobalt, rhodium, iridium. Oh, this one is hard. It's meternium, something like this. Like the whole syntax is fucked. Meternium. I have nickel, palladium, platinum. We have darmastadinium. I have copper, silver, gold. I have roentgenium, zinc, cadmium, mercury, copernicium. And then there's a stop here because I have to go somewhere else. And where the fuck am I going? Okay, here. So I think this is the end of the D block. The D blocks are done. So now I have to go and do the whole P block, right? And it starts with boron, aluminum, gallium, indium, thallium, nihonium, carbon, silicon, germanium, tin, lead, flerovium, nitrogen, phosphorus. So phosphorus is the pillow thing in my head. Then I have arsenic, antimony, bismuth, moscovium, and then I have oxygen, sulfur, and then I have selenium, tellurium, polonium, livermorium. And then there's a stop here because I actually have to go somewhere else. And then it's like, it starts with fluorine, fluorine, and then chlorine, and then iodine. It's, I think, fluorine or fluoride. No, I think fluorine. Fluorine. Fluoride, chlorine, iodine. I don't know. If fluorine or fluoridine, I'm not sure of the two. Chlorine, bromine, iodine, right? And then I have, I am right here at this point. So I have astatine here. I have tennessine. And I'm moving back in the kitchen, and I have neon, argon, krypton, xenon, radon, and Oganesan. And there's a small pause because I have to move. And then I have Lantatum. These ones are hard. Like the next few that I'm gonna say is super fucking hard. Lantatum, Cerium, Praseodymium, Neodymium, Prometheum, Samarium, and then I have Europium, Gadolinium, Terbium. What the fuck is there? Oh, this one. Dysporsium, Holmium, Erbium, Thulium, Ytterbium. It looked really like Ytterium that I said earlier, but like this one is Ytterbium. And then we're in like the final stretches, right? And then I have to go actinin. Oh no, it's actinin. No, actinium. I think it's actinium. Thorium, protactinium, uranium. The fuck is there? Neptunium, plutonium, americium, curium, berkelium, californium, einsteinium, fermium, mandelbrium, and nobelium. And then we're done, right? This is it. So that's it. That's the whole thing. Did I get it right? Anybody checked? I believe the purpose is to balance Mary's technique and show this is a good way to memorize. Yeah, and there's a link to like how the actual brain is encoding, right? I didn't spend days like learning this shit. Like I literally did it last yesterday, and like I have the tweet when I actually started to do it because I posted as soon as I was done. It's not that it's not even that did I miss bromine? No, I did bromine when I was saying fluorine when I was fucking up here, chlorine, bromine, and then iodine, and then it was the astatine and tennicin here. Yeah, almost fucked it up. But you know when you don't know something, right? Sometimes I was doing it, and there was one in my bed, in my second apartment. I always missed it, and the reason I missed it, it was not salient enough. So the thing you have to really do when you're learning something like this is you have to make it as, I don't know, man, like as human salient as possible for you. What is triggering you like salience, right? And that's what you should do. For me, it's like colors and smell, stuff like that. So a lot of the stuff are either stinky or dangerous or like very vivid, right? So like we can go through the loci, but like the funny thing is that you can say any of the right now, right? You can say any of the elements, and I will know which one comes before and after. So for instance, if we try to take it back and go to palladium, I know that right before palladium is nickel, and right before nickel is meitnerium, and right before this it's iridium, and right before that it is rhodium, and right before this also is cobalt, and then I have to go like a full sub palace back, and then I can go this way also, right? So that's the setup. Like it's a very powerful technique. It's one of the most powerful if you need to encode stuff in sequence, because it's used literally almost like accessing the raw power for memory in your brain, and like wasting it on that type of stuff, right? Instead of like learning places, you're like, yeah, this is a place. No, I'm telling you, like hippocampus, this is a place, right? It just happens to be also similar to some place you went, and we have to encode this stuff because it's very useful. And then that's what's happening, right? We have a bunch of questions. That was fun, all correct. Yahoo! We did it. What's up, my dog? Hope you are having a good time. We have a good time, Surfer. This is actually fun. Thank you, Justin. I made a similar with mnemonic, but it takes some more time to memorize, and I just remember the symbols. Yes. So there's a gradation. If you there's on one side there's rote memorization, which is just purely text. You're just like looking at letters and stuff. At the far end side, the most potent one for memory is this, right? Because there's a lot of energy you have to go to actually make the map, right? And the map doesn't have to be a real thing. You can take like whatever you want, right? You can take a fake map that you're building, or you can like mash stuff together. Like I mash stuff in my memory palace. Like if you look at it here, this first one is my childhood home, right? This one and this one also, right? Actually, these two were outside until lithium were outside, and then after that we're in the house, right? And like when I'm out of the house with radium, I'm taking a van, right? I'm literally taking a van all the way to my first apartment, which was a mess. The first apartment was a fucking mess. So here we're still outside of this first apartment. This one is inside, but like in the hall. This one is just next to like the landlord that was a bit a crackhead. So like all of this map to like specific location, and I know exactly when they stop, right? So if you look, when I'm getting out of this apartment is here, right? Here, this is the other, this is my second apartment, and it stopped at Hassium. It stopped here, right? So this is in the garage outside, and this vanadium is when I'm coming with the van and I'm crashing the van on a stop sign, right? So like you see, like you can connect a lot of stuff together, and like the people that are very good at memorizing like random shit, right? They have this massive palace, this massive map they created. So they're not really good. They're not necessarily have like a massive memory that like they're better than everybody. They just spend a whole lot of time making a map, and the map is the thing. And now they're using this map hack to encode whatever they want, right? And then you also have to be a bit creative to like get to your salience rapidly, right? And this you have to know yourself, what like is very salient for you. Okay, what was it like to teach this to schizophrenic? Very fucking hard, actually. I tried to teach that to a schizophrenic. Actually, Ana Elisa de Sousa, my colleague, was leading this. I was just helping out. Memory Palace. Which one is that? Is it this one? Wait. Schizophrenia. Yeah, I tried to pull out the. Yes, this one. So what he's talking about is this. So Ana Elisa Sousa, great guy, keep it up. And me, we were running a feasibility study for the method of loci, and we're trying to improve. The issue with the schizophrenic is like they have poor working memory and all this stuff, and like they actually don't want to do it because it's hard. Like it's hard in the sense that if you don't think that it's gonna be worth it, you're not even gonna make the map properly, and like you're not gonna encode the stuff properly. But the one thing is that they were all able to recall whatever map they were doing, right? It's just that after, like if you try to do it in one session, they're gonna be completely tired after it. Like it's a 3-hour rough session with people that like have other kind of issue, right? When we did it with like healthy people, in 3 hours they could all learn it, and then they can learn multiple ones, like multiple multiple random sequence one next to the other and recall them. Use the same method to learn order and names. Did you associate name with something else? What do you mean? Order and names. Like the method of loci is to like have the orders and name. So the sequence is this. You create the loci. So I have all the maps set up, right? All my maps over here are all set up prior. So you figure out the loci first, and then I put the elements next to it, and then I imagine, right? So if you look, hydrogen is a cool futuristic car for me. It's like a futuristic hydrogen car. This is it. The helium is a big balloon. It's literally a huge balloon in the garden, right? And then the lithium is a big battery that is leaky. It's like dangerous. And then the sodium is like literal salt in the stairs to climb up. And it's like, it's hurting a bit because like, I don't know, like in this particular setup, I have a wound or something, and then it's hurting. And then I have the phosphorus, right? The potassium here, that is like a bunch of monkeys. They are just in the door. And then after that, I have rubidium, which is my old bed that used to be there. It's not there anymore, but I decided to put it there in this little chamber. And like in here, there's a whole bunch of rubies in the bed, right? And I was like, I wanted to go sleep there, and then like can't because there's a whole bunch of rubies. And then Casium and Francium is like literally Caesar and Napoleon. They're all chilling in the living room. One is eating a Caesar salad, right? And the other one is like on the sofa sleeping. He's like 50 years old then, so he's like all beaten up. And then there's this horse next to him in my sofa. I was like, shit, I can't even watch TV here. And then I move on, right? Like that's kind of how you do it. Yeah, doesn't matter. And then, like this, I spent exactly like, I don't know, 10 minutes just thinking about it. I took the first thing that came to mind and I amplified it and then I put it there and then I moved on, right? I noticed you recall the element at the start of each new location very quickly, but it didn't seem to take a little longer from the element further down the path because I had to actually move, right? And you see, some of the stuff took time because there was a longer period of time where I had to move. So molybdenum is a good example, right? If you look at it, molybdenum is over first apartment. Yes, here. Like it's here, molybdenum, right? The space between here, the door for my apartment and the kitchen table, it's kind of big, right? So what happened is that the door is here, right? And then there was a hallway like this, and it turned a bit like that, right? And then in here, it was the kitchen, right? Like this, right? And then here the hallways continue, and then there was a small washroom over here, right? There was a door. It didn't lock properly here and here, and then this is where the bedroom was, and then the big window is over here, and then it was like this, right? So molybdenum in my memory palace is right here at the door. Chrome, it was here, right? And then like if I was to think about it, here it was dubnium that was here, and then over there it was like tantalum that was here. So the space between here and here, I literally had to walk, and I asked myself like, is there something here? Because I could have put something there. It was salient for me, this little corner, right? But then I didn't. I put it here, and then at this point I had to look, right? And I usually look here because my wife was like, I don't know, like there and stuff in the kitchen table. So I look here, and this is where I had tungsten, right? And then I looked here, and this is there was like a sink. I was doing the dishes. So, Cam, if you're seeing this, I was the one doing the dishes. Here there's cyborgnium, right? So it's like a cyborg that looked like a fish that is over there, right? And then I had to move, right? I had to, like, I was looking, but then I had to move like this and go into the washroom. There was Naruto taking a piss here. So he's over there. And then I had to look here for something that is happening in the window, right? And my wife is there, but there was a lot of net, and the net were like all techie. So we can see outside because we like to see outside. It's technetium here. And this one I had trouble because it's all honestly a poor... just a poor imagery here. This is rhenium, right? And then there's a small door over here, and I had to move there, right, in order to be in this is where bornium was. There's another big table here. This table is reused throughout because we kept the table forever, right? And then here there was the iron stuff. The sofa that was there is in iron now. There's a horse in the balcony that is in root, right? So it was like it was all fucking crazy. Here in the garden there was like osmium, and then just here in the garage that is just below that there's hasnium. Whole bunch of asses on the garage door. I did my best for this one. I struggled a bit. So like when you see me stop for a while, it's because I'm actually moving, right? And I literally am moving in my head to be able to look at these. Okay, great technique. I will try. Is it because the brain has to take a moment to mentally travel? Yeah, exactly. This is what you're doing. You're literally traveling your map, right? There's better, like you can optimize in order to do it fast. You can optimize these so that it's good. And if you've seen like in between these two, I had to stop because literally I had to take a car, and this there was like a cutscene, right? Happens, all black, and then fade, and then I'm going to the next like chapter or whatever it is. That's kind of setup. I could have maxed out a bunch more. Like in the S block in my first chill house, I could put 50 things in there, but then I also needed to kind of fit the structure, right? So like I made some trade off. Can't see the screen. Oh, can you see it now? I think everybody see the screens. Yeah. Well, can you guys see the screen? You should be seeing the screen. Yeah, you should be. Let me know if you see the screen. Graph A like so is in the embedding of the LM in like graph because its arrow and direction is like an edge and the concept are the nodes. So it's a not really. No, the LMs are not like that. It's not the same kind of structure. I actually think that the LMs don't have this concept, and like it's fine if they don't, because they're not human like, right? Like they don't have this concept of being in the physical world, so they don't need this bias to actually make the map constantly, right? So that's kind of the difference we have with them. So sometimes like they're doing weird stuff and you think that they should be doing the right stuff and then they don't. It's because of this like difference in how we actually learned about the world. Okay, how would you go about memorizing the atomic mass as well? Super great question. So the atomic mass here would be a bit difficult, right? But basically what you need to do is just like do a double encoding, right? So you try to encode this number, right, into also the image. So in this case, it's the hydrogen element, right? And then you encode something that like make you think about this number 10079. Sometimes it's difficult, right? So if it's like very arbitrary number, you're gonna have a hard time. So you could still do it, right? You just have to figure out what 1 and then 20 and 79 make you think about, and then put it also with the hydrogen car, right? If you can do that and find a good like representation for this embedding, you should be good to go. Same thing for these, right? Yeah, that's kind of it. It's kind of the stuff. And then you can like do even more encoding for like different aspect of it. Let's say the metalloid, the halogen, the non-metal. In my case, I just did like rough groups, but then you can go a bit deeper in it and prepare that. Cool, perfect. If I had known this at university, my first chemistry class would have been easier. Yeah, like, and honestly, like, it's very versatile. It's not just about like, what's it, like, memorizing random shit, right? It's the deeper meaning to it that like you have this innate latent capability to create maps. Like, none of you are struggling with any of this. There's no way you're going about the world and you have no concept of like internal maps of knowing where the stuff are. Otherwise, like, yeah, you'll have more serious trouble, right? And your brain is using that fact to learn. Like, they are tightly coupled. So whatever you can do to kind of get closer to that will make whatever you're learning much easier. Okay, so that's this. Let me know if you have other question about that. And I wanted to end up here on what the fuck is Jan saying? Because then, like, you're like, we're gonna get to maybe you're in the camp of like, we're gonna get to AGI and like the general intelligence that is like more human-like, that can do discovery and like be embedded in the world, whatever, just with LLMs. It's enough. We just need to scale, I don't know, reinforce learning the heck out of it, all of this stuff, right? And his whole premise is kind of based on that, is that we have a world model that is grounded into the reality, right? Our world model and the one from, I don't know, man, like flies is different, right? Like, I cannot climb in walls. So I don't have this kind of 3D perception. Like, I'm very tightly bound to gravity. When I'm moving into this space, I'm not floating around like this, right? I'm literally walking. And sometimes I'm falling, right? Sometimes when I'm in the balcony, let's say with the ruthenium, and I have to go and to look at the osmium, I have to jump the balcony and then be on the floor. And then I can see the hafnium on the garage, right? but like I have to do these movements. Same thing when I'm in the actinium, right? I have to jump a balcony to go down to thorium, and then I can like do the little walk that I'm doing. So like we're tightly bound to like the physical world, and that's kind of how our brain is learning. I'm not like in like a high level 2D map looking at the stuff, or like a 1D version of it. Like it's not even this, right? It's like a 3D world where I'm bounded by gravity, and then there's smells and like a vision and a tactile element to it, and salience that are related to my safety. Like that's kind of how I encoded best, right? So what he's saying is that if we want to reach human level of intelligence, you kind of need that, right? You kind of need some aspect of it that understand how the world is actually working, right? And to do that, you can't just go and use human generated output, because even us, if you just look at human generated output, let's say you look literally just at the text, it won't work. Like the actual learning is fucking hard, right? You see that, like you seen that, like this stuff. If you're just trying to learn hydrogen, lithium, sodium, but that, like, yeah, now you're gonna take like 2 months to memorize it, and like you have to brute force your way through it, and like the recall will be brittle. In my case, I looked at this stuff. I think I've went through it fully 3 times, right? One time when I was done, one time in the shower, and one time today. Right? That's all there is. And then not one right now, right? I didn't have to kind of go and do like a lot of memorization to do any of this, because I'm using something that my brain is really good at, which is the physical domain, right? And yes, you can tack on some language element to it. It doesn't matter. But the underlying structure of memory is, and like how this my being function is tied to this kind of world map. What he's saying is that in order to get there to human level intelligence, is you need to have understanding of the physical world. Otherwise, like we're always going to have a discrepancy between us and the thing. And maybe it's fine. Like this is what I'm saying, is that maybe it doesn't matter. Maybe it's like not even important to have I'd say it like a human level tight connection like this, right? But if we want to have that, right, and like be very empathic between each other, right, like the artificial and ourselves, it will be much better if we actually have a shared physical world that we can all think together, and then like get on the same page, right? That's the core idea. Having persistent memory is another one. Ability to reason. So these two, in my view, they're tightly related. If you're able to have a physical world, you can create persistent memory using that as a substrate. Ability to reason and plan also is very tightly to it. So ability to reason and plan, they're tied to this world model that you can use as a simulator in some sort of way, right? So like this whole thing that I was able to do was because I kind of planned in that world model that I picked from real stuff, right? So I made this first, and I put it there, and I can plan and my path, and then I went through it, and then I can reason about what is the stuff that is there, what's the puzzle, because each of them is kind of a puzzle, right? Palladium is like a paladin from World of Warcraft. I don't even know like if it's a thing anymore or whatever it is, but it's in the sulfur and he's heavy, right? So what's that? And then I respond to it. Some of the imagery that I created, they're not great, right? I could have refined them a bit better. So the puzzle is a bit harder. And you see, I struggle sometimes with the ending. So fluorine or fluoride, like it's a bunch of toothpaste on a on the staircase, right? I'm not sure which one is it. So there is still some sort of like a thinking about each of them like this. And when I did it right, Seaborgnium, for instance, it's like instantaneous, because it's a really good one. So what he's saying is that the optimization of objectives is required to get that. Like if you want to get this, you have no choice but to have like this kind of objective optimization element, right? So you observe something with your perception kind of modules, right? Can be all that kind of sensors. And then if you want to have the correct output about what you should be doing, right, there's a representation that needs to be created and an objective kind of function that need to be optimized for, right? This is how you kind of train, right? And this makes a lot of sense. If you see babies, sometimes they don't have this objective well calibrated to the actual world, right? They're going to do something and it's like you didn't know this will happen and they fall and whatever, it's big because their kind of world model of like what this is supposed to be is not very accurate. Same thing for us if we do other things that are outside of our not comfort zone, but like stuff that we never did before, right? So if you're trying a new sport or whatever it is, maybe you'll be like, whoa, what is happening? Then like your world model is kind of calibrating on that, and now you understand a bit like how the motion and the spatial aspect of it works here. So here, to be able to do that, it requires system 2 thinking. So system 1 is just like automatic. System 2 is like being able to kind of reason through it and not have it literally within the weight, but like being able to have it like created on the fly. And it require more like longer thinking, high latency process basically. So thinking fast, and then this is the thinking slow part. He's saying that like having a general internal world model allows for predicting this objective. So the objective that we're talking about here, right? If you do have a world model, then what you can do is you can have like a maximum sequence on it and then like try to figure out what's up. And for us, it's also even better because we can have guardrail objective so that you don't do something really wild, right? And we can ground that into what we understand versus the textual world and the semantic world of LLMs. And then you can more tightly, I'd say it like keep these things in check, right? And then there's a task objective here. But they all stem from the world model. And there's some element of memory in there, but like it all stem from here, right? And what he's saying is that this is hierarchical. So basically you can do a whole bunch of simulation. So if you're trying to go somewhere else, you can simulate how you're going to actually do it. Right? You're not going to start to think that you're going to fly away and then like, or fall on the floor and whatever it is, right? It's tied to your sensory understanding of the world. And this is encoded in the world model, how this world model specifically works. If your world model is, I don't know, man, like World of Warcraft, right? Or RuneScape, or like, I don't know, Elden Ring, whatever, and then you have your world model here, it is bound by the action that this thing can take. So if you can climb a mountain, well, fantastic, great job. If you can fly, then you can fly, right? But if you're grounded into something that you know, like you can't like phase through walls and stuff like that. And if you try to do this, it will add kind of a mental strain because you have to learn the rule first and then like encode it into that world after that. But here, basically, like there's subtasks for each graded task, and like this having a world model as the middle ground can allow you to kind of have this hierarchy and then like run this simulation in it. And there's this whole idea of JEPA, right? That's kind of the thing in a nutshell, is that it won't be AGI or however human general intelligence won't be like one thing, right? It will be like a collection of a bunch of different things, right? And LM has a place in there, most likely, right? Maybe in the memory element. But here, it will be kind of this multi-component aspect. But the world model is an important piece. Like if you don't have this kind of world generator or like something that is like binding what can happen and what cannot happen, you won't be able to like get something that is thinking a bit more like us. And there it is. Like he's saying that like for 15 years he thought like this whole thing could be done with generative model, right? To be able to generate from, let's say, a video, you mask it and try to generate the stuff. And what happened is that this is very brittle because he doesn't understand really how the world works. You look at videos, try to kind of mask it. So if something else happens that was not in the distribution, they don't know what's up, right? They're not able to do with these models. So he's proposing joint embedding predictive architecture, so JEPA. And JEPA is like the same thing, but instead of like doing the generative part, you're trying to predict abstract representation, right? So you're always in latent space. You're never trying to go into the pixel world, except in the decoder part, right? But like the whole thing that is happening in the loop is always in the latent space. And this can work for many type of sensory input, and you can like mix and match a bunch of stuff. And what they're doing at the moment, sorry, we're okay here. Are we seeing this stuff? Shit, just give me a second. Yeah, I can't see that. Okay, anyway. So where they are right now with this is they've done VJPA 2, so it's on video now. It's a self-supervised video model that can enable understanding prediction and planning, right? But at the core of it is this idea of like creating this world model, and it's self-supervised. It's kind of like the next token prediction type of thing that we pre-train like language model on, but on another on another modality. And what they realize is that by doing this, right, what you can get is some pretty interesting thing. Like you can get like state of the art on a whole bunch, and then you can take this like learn kind of world model type of thing, and then put it into post-train it on a latent action conditional world model. So something that will be able to have an actuator and like actually move into the world with a robot. And the robot is a Franca arms, right? So it's like an arm that can move. And in 62 hours, right, you're able to post-train it, and you're able to do zero-shot task on that arm, right? So basically, like you achieve all of this without more data from the robot in this environment and without any specific training or reward, just because the model understand and has a world model. And based on that, you just need to calibrate about like what's the actuator that I'm actually moving, and then you can act to do the prediction of the next step, right? Depending on the task, and then do the movement that need to be done, all based on like video understanding of the world, and then having this latent kind of joint embedding representation training. So that's it. So this is the whole thing. Link these two. They're very interesting in the description. But that's basically it, right? So like if you had to like keep one thing in mind from this whole thing is that your brain is kind of primed for a specific thing, and it has to do with how we evolve, right? Like and how we're going around the world. So if you were trying to make if you're trying to use your memory and learning capability to the fullest, you kind of have no choice but to leverage this, right? And it's like a free lunch. If you do that, it's much easier. If you don't do that, it's just gonna be hard, right? And it doesn't depend on a different type of like this is something fundamental for humans. Like they're like most humans, they go to some place and they actually map stuff as they go. If they are not able to do that, they have much bigger problem, right? And this element, this is core to the human, is a required component with from Jan LeCun if we want to get to human level of intelligence. And one of the model that is like this is JEPA. So if you want to check this out and then kind of link the two together, you can check it out the paper. And it's starting to getting interesting, I would say. Like I would not sleep on that if I were you. Okay, any question? Macaron say I will use it today to study. Cool. Yeah, good. Do it. It's a very useful technique. Yeah, you have on your back pocket. Any question, folks, for anything here? It was actually fun. I really like to, I really like to use this. I was a bit stressed, I would say, at 1 a.m. But after I got out of the P block, it was not too bad. So that's it for today, guys. I wish you all a fantastic weekend. I hope you learned something.